Hello and welcome to Organic Chemistry Lesson 1. Today we're going to be focusing on knowing the components of crude oil and some of their properties. So to get you started, I'd like to pause the PowerPoint and have a go at the starter questions, please. So how is crude oil formed? What do we use crude oil for? And why is it described as non-renewable? Okay, so let's have a look at the formation of crude oil. Now, crude oil, along with coal and natural gas, is what is known as a fossil fuel. It takes millions and millions of years to form. And the way this happens is that in the ancient seas, millions of years ago, there were lots of organisms living. When they died, they fell to the seabed, and over time they were buried with layers of sand and sediment. And eventually this built up and compressed into sedimentary rock. And the layer of dead matter, dead organisms, under the heat and under the pressure and in the absence of oxygen over millions of years, bodies started to form crude oil. So it's really important to remember this process takes millions of years. And what I'd like you to have a quick look at now is, can we pause the PowerPoint here and can you go away and Google whereabouts in the world oil is extracted from? So this is an interesting little map I found on a website called Frac Tracker. It's really interesting. So the orange is oil fields and the black circles are oil refineries. So the bigger the black circle, the larger the amount of oil refineries in that area. So you can see it's quite heavily concentrated around Europe, not so many in Africa. Along Eastern Asia, there's quite a few, not so many in Australia, and quite a lot in North America. And while there's a less amount of oil refineries in South America, there are a lot of oil fields. So this may come into play in future years as the oil starts to run out. Okay, so we call crude oil and coal and natural gas a fossil fuel because it is made from the remains of dead organisms that lived millions of years ago, but it is also a non-renewable source of fuel. So non-renewable means it is being used up faster than it is being made. So we will run out of it a long time before any more is able to be made. So we'll need to look at alternative sources of fuel. So what I'd like you to do is pause the PowerPoint here, and I'd like you to go away and look up some examples of renewable and non-renewable fuel resources. Okay, so you've gone away and looked up sources of renewable and non-renewable fuels. How many did you get? So our top 5 renewable sources of energy are solar, wind, water, biomass and geothermal. And non-renewable, there is coal, crude oil and natural gas, but there is also nuclear. Now nuclear fuel lasts for a very long time. However, there is only a finite amount of uranium and plutonium on the planet, and once that is used up, it's gone and we will have no more nuclear fuel, but this is unlikely to happen for quite a long time. We're talking thousands of years. Okay, so once crude oil has been extracted from the ground, it's not very useful. It's not very flammable and it's not much good as a fuel source. So what we need to do is to separate out the useful elements in crude oil. So crude oil is a really complex mixture. It's got hundreds of different chemicals in it called hydrocarbons. And they're called hydrocarbons because they are chemicals made up of hydrogen atoms and carbon atoms. Okay. Now these hydrocarbons can be really useful, but in order to get them to be useful, they need to be separated from each other. And this depends on a process called fractional distillation, which works with the individual chemicals' boiling points and condensing points in order for them to be separated. Okay, before I start talking about fractional distillation in any detail, I just want to quickly recap what distillation is. So distillation is where two liquids are separated based on their boiling points. So the liquid is heated, the one with the lowest boiling point evaporates first, it then rises up the column and is collected and condensed. So you have two separate liquids at the end of the process. Fractional distillation works in a similar method, except instead of separating two liquids, you're separating hundreds of different chemicals. So in fractional distillation, crude oil is piped in to the bottom of the fractionating column, and it's heated to a very high temperature, 350 degrees. Now at that point, most of the chemicals, the hydrocarbons in crude oil will vaporize, they will turn into a gas. However, some won't. These are the really, really large molecules that need a lot of energy to turn from a liquid to a gas. So the hydrocarbons that stay liquid are tapped at the bottom, and they are used for bitumen, which is like tarmac for the roads. Back in the fractionating column, the gases will start to rise. Now, as you go up a fractionating column, it gets cooler towards the top. The temperature changes from hot at the bottom to cooler at the top. Now, as the gases rise up the fractionating column, they start to condense at their boiling points, which is in different positions. So heavy fuel oil will condense at still quite a hot temperature, about 300 degrees, and that is fuel used for ships and power stations. A bit further up that, so a bit cooler, diesel will start to condense, and that is fuel for cars and trains. Further up again, we have kerosene, which is aircraft fuel. Further up again, there's petrol, which is fuel for cars. And then some chemicals will rise right to the top of the fractionating column, and because their boiling point is below 24 degrees, they will be tapped off as gases, and that's the liquefied petroleum gases, and that's fuel for domestic heating and cooking, what provides the gases for our Bunsen burners. Okay, so important to understand that the hydrocarbons with lower boiling points are smaller molecules. So they have low boiling points. They are very volatile. That means they react really easily. They flow easily, and they ignite or catch fire very easily. In comparison to that, at the bottom of the fractionating column, where we've got hydrocarbons that boil at a high temperature, these are larger molecules. They have a high boiling point. They're not very volatile. It takes a lot of energy to get them to react with anything. They don't flow as easily, so we would describe them as more viscous, and they do not catch fire easily. So they're kind of less useful as fuels, because you want a fuel to catch fire and burn to release the energy. So between these large molecules, we say there is a high attraction between the molecules. So it's a force a bit like gravity. So the molecules are attracted to each other, and it takes a lot of energy or a high temperature to overcome those forces and get them to turn into a gas. So these forces need to be overcome so the molecules can separate into a gas, whereas the smaller molecules, like the petrol molecules, the liquefied petroleum gases molecules, they have a low attraction between molecules, so they don't need a very high temperature to overcome the forces between the molecules and separate out from a liquid into a gas. Okay, so we've had a look at how fractional distillation works, and I just wanted to mention a few more things. One, when it says it's separated into fractions, fractions are a smaller mixture of hydrocarbons. So, for example, petrol isn't made up of one chemical. There could be 10, 20 different hydrocarbons made up of petrol, but it is a smaller mixture than that of the original substance, crude oil, which has hundreds and hundreds of different hydrocarbons in it. Another thing to remember is that you will need to be able to provide examples of the different fractions and know whereabouts roughly out of the fractionating column they are collected. So there is an acronym to remember. So lazy penguins keep drinking hot beer, and that goes from the top of the fractionating column down to the bottom with the bitumen. So what I'd like you to do now is to have a quick look on this BBC Bite Size link, have a watch of it, and we can use it to answer the question I'll be asking you next. Okay, so now we've had a look at how fractional distillation works. I would like you to have a go at this exam question. It is explain how crude oil is separated using fractional distillation, worth 6 marks. So, as always, with long answer questions, you need to make at least 6 points. And on the topic of fractional distillation, have a think about what really needs to be included. So, what process is involved? what are examples of the products produced during fractional distillation? Is there any further higher detail that you could go into? So have a look over your notes, have a look back at the last 2 slides, and then give yourself 10 minutes, see what you get down. Okay, so now you've had a go at that question, grab yourself a green pen if you've got one to hand, and we'll have a look at the mark scheme. So there's 1 mark per point. Now, it's really important with long answer questions that don't just stop after you've made 6 points. Carry on going. That way, if you've made a mistake on one of the points, you might pick up the mark on another point. Okay, so 1 mark per point for any of these. So first one, crude oil is able to be separated because the different chemicals or the different hydrocarbons have different boiling points. The crude oil is heated until the majority of the hydrocarbons are vaporized. The part that remains a liquid is tapped off to use for bitumen for the roads. The vapors rise up the column. The column gets cooler the further up the column you go. The different chemicals or hydrocarbons condense at different temperatures and are tapped off. Larger molecules with higher boiling points, such as heavy fuel oil and diesel, are collected towards the bottom of the column. And you could say this is because the molecules have a stronger force of attraction to each other because they are larger. That way means they need more energy to overcome those forces in order to be able to evaporate and boil. Smaller molecules with lower boiling points, such as petrol and kerosene, are collected further up the column, and you could go on and add that these smaller molecules have smaller forces of attraction between the molecules, so they need less energy for those forces to be overcome in order for the molecules to vaporize. And for the last point, you could say some vapors do not condense at all and are collected as gases at the top of the column because the top of the column isn't cold enough for those gases to condense. Okay, so tot up your marks and see how many you got right and see where you could add in any other points that you may have missed. Okay, for the plenary, I'd like you to have another go at the 3 questions I asked you at the start and see how many of these you can answer now. So go ahead and have a go and just pause me here and I will go through the answers in a moment. Okay, so question 1, how is crude oil formed? So it's formed from the remains of dead sea creatures from millions of years ago that fell to the seabed. They were covered up by sand and sediment, which formed layers. And under the heat and pressure and absence of oxygen, the dead sea creatures were formed into crude oil. So question 2, what is crude oil used for? Crude oil itself is not used for anything because it's not very useful. However, it is separated into fractions which are useful, such as petrol, diesel. So crude oil is used for fuels primarily and also as bitumen for roads. Okay, question 3, why is crude oil described as non-renewable? This is because it is being used up at a faster rate than it is being made. Okay, thank you for listening. Head on over to Educake to have a go at the quiz online. Thank you.